I would like to welcome you to a mathematics lesson which is on statistics, and basically we are going to look at standard deviation and variance, how we can do the calculation of those. I am Mr. Malama Moses, who is going to present this lesson today. So now let's come to our lesson. So at the end of this lesson, you should be able to calculate the variance as well as the standard deviation of any given data set. Now, variance and standard deviation, these are simply measures of dispersion. What do we mean by measure of dispersion? Anyone who knows what it means, what it implies when we say it's a measure of dispersion in statistics? Okay? So a measure of dispersion, it helps us to see how widely spread data is. Because in statistics, basically we collect data. Once we collect data, we have to analyze this data. When we analyze it, where possible, we have to present it. Okay? Now, when analyzing data, we use two measures. Measures of central tendency as well as measures of dispersion. Probably, maybe, let me ask you what are some of the measures of the central tendency? Measures of the central tendency. Measures that help us see where centrally this data lies. Yes, you would.
Mean.
The mean, one. The next one?
Mode.
Mode. Yes, yes.
Median.
Median. That's very good. So those are measures of central tendency. And then now we have measures of dispersion that helps us see how widely spread the data is, because these are very important measures that you need to know. Yes. You need to know. In order for you to come up with a correct conclusion of the data that you collected after a survey, you need to know how to calculate these.
Yes.
How to get?
Yes.
Yes. So, without wasting much of your time, I'll go ahead and show you the formulas that we use for calculating variance and the standard deviation. Okay? So now, how do we go about doing that? So, letting variance and measure, and so calculating variance and the standard deviation. Okay? So remember I said that that is variance and the standard deviation I said that these are measures of dispersion. Okay, so they help us see how widely spread the data is. Now, for grouped data, we can just go ahead here. For grouped, let's start with ungrouped. For ungrouped data, in order for us to find this variance, we will have to find the differences in distance from the mean and that data, and then we square them, then we divide by how much data we have.
Yes.
Okay? So in short, we are saying that variance is the average distance, or the difference in mean and the data in distance between the mean and the data of a given data set.
Yes.
Out there?
Yes.
Yes. So the variance is simply the average distance between the mean and the data of a given data set. So what do we mean? So for ungrouped data, variance can be found by using the formula variance equal to, so we are saying that we are adding the differences between the data, which we call x minus the mean over the total frequency. The total frequency. Out there?
Yes.
So variance is equal to the summation of that one. Now, because when we are finding the differences, some of the differences will be negative, right?
Yes.
So to avoid that negative thing, we square this part. Okay?
Yes.
Square that part, so that we have now the formula for finding variance to be variance is equal to the summation of the difference between the data and the mean squared over the total frequency. Okay?
Yes.
So the alternative formula, when you work this one out and simplify it to express it in a different form, it will also be the same as variance equal to the summation of x squared over the total frequency and then minus the mean squared. Okay? So that's what we simply use. So this one is for variance. For group data, this one is also the other form, the alternative form, the simplified form as well. Okay?
Yes.
Yes. Now, what is the standard deviation? What is the standard deviation? So standard deviation is simply the square root of the variance. Okay?
Yes.
Standard deviation is the square root of the variance. So standard deviation is the square root of the variance. Okay?
Yes.
So what do we mean? For us to find standard deviation, we have to square root what? The variance. So simply, some of you may have already guessed what the formula we can use for standard deviation. Not so? Yes. So for standard deviation, it is standard deviation will be equal to the square root of, first of all, for that one it will be x bar squared, which is the mean, over ln.
Yes.
While for the other form, let me simply be using SG for standard deviation. It will be the square root of the summation of x squared over n minus x bar squared. So this square root is for everything.
Yes.
Let's see, that's a question there. Mostly, most of the learners usually put the square root only on top, which is not correct. The square root is for the whole part there. Okay, so let's look at an example for ungrouped data when it comes to calculating standard deviation.
Yes.
Yes, you have a question?
So, since you say both formulas are same, now why is it that the second formula n is not over everything, whilst the first formula n is over everything?
Okay, so why the n does not appear also on the other one? When we are simplifying this, okay, I would have shown that, but it may take long for me to show how we come from this one to here. So when showing here, the n only remains here for this formula. But the n will still use it when finding x, when finding the mean, because the mean is simply, what is the formula for the mean? What is the formula for the mean? Summation of x is I. For ungrouped data, summation of x is over this n. Have seen that? So this x bar will have an n in it here. Okay? Yes. So we can go to our example now. Okay, suppose we have this data set here and grouped. Probably it could be goals scored by a player. Okay? A football player. Maybe in the first game he scored 4, the second game 1, the other game 3, the other game scored 5, 3, 2, and also another 3. So let's say these are, this is the data that we have. And then we say let's calculate the variance and as well as the standard deviation. So what are we going to do in order for us to calculate the variance and the standard deviation? So what we are going to do, we are going first to find the mean. Remember there's the mean in the formula? Yes. So we'll start by finding the mean, and then after finding the mean, we'll find the variance and the standard deviation using the formulas that we have. Yes. Okay. So now let's start by doing the mean. Okay, solution to our problem there. So we are saying here we calculate the variance as well as and the standard deviation. Okay. So now, let's go to the solution on this other part of the book. So we are saying that we start by finding the mean, which is x bar, the mean, the x bar, which is equal to summation of the x's over n. So when we do that, we are going to have, you can be telling me 4 plus 1 plus 3 plus 5 plus 3 plus 2 plus 3. Everything divided by how many do we have? 7. Okay, so let's add this quickly. 4 plus 1? 5. 3? 8. 5. 13. 3. 16. 2. 18. And then plus 21. So this is 21 over 7. Giving us the mean to be what? 3. 3. Right? Yes. Yeah. So since the mean we have found now, we can go to the variance and then we find the standard deviation. Right? Yes. So the variance, we are saying that it's simply the average distance between the mean and the data set that we have. So according to the formula, we said that we find the variance by saying summation of x minus x bar, but this we square over n. Yes. What does this mean? We subtract each data from the mean and then we square, we add everything. So we are saying variance is equal to, so the first one is 4. We are subtracting from the mean. What is the mean? 3. Minus 3, so this will square plus 1 minus 3, we square plus 3 minus 3, we square plus 5 minus 3, we square plus 3 minus 3 square plus 2 minus 3, we square plus the last one is 3 minus minus 2, which is 0.
Yes.
Okay, I'll just put 0, we square.
Yes.
Good. And then the whole thing over 7. So you can go to the next step. 4 minus 3.
1.
1 squared.
1.
1 minus 3.
Negative 2.
Squared.
4.
3 minus 3.
0.
Squared.
0.
5 minus 3.
2.
To the power 2.
4.
3 minus 3.
0.
To the power 2.
0.
And then 2 minus 3.
Negative 1.
Power 2.
1.
That's 0.
Yes.
Okay, we have everything.
Yes.
Good. Over 7. And then when we add everything, what do we get?
10.
10. And then divide by 7. We can use our calculators. Feel free.
1.428.
1.4285. 719. Yes, but we are encouraged to approximate this to 3 significant figures, which would be what? What is this to 3 significant figures? Yes, Grace.
1.429.
To 3 significant figures. 3 significant figures. Yes, Zoe.
1.43.
1.43. So this is to 3 significant figures. Are we okay? Are we together?
Yes.
Any questions up to here?
No.
So this is the variance. Right?
Yes.
Yeah. So therefore, the standard deviation now will be standard deviation will be equal to the square root of the variance, which is simply the square root of 1.4285579. So let's avoid using the approximated one. Right?
Yes.
Let's avoid using the approximated one. Let's use this one. Okay? To find the square, the standard deviation. Yes, Sylvie.
So, sir, if you use more than 3 significant figures, the answer going to be wrong or correct?
It's not wrong, but we are just advised to use 3 significant figures according to our curriculum or syllabus. Yes. We are encouraged to give non-exact answers to 3 significant figures. It is correct. Up to here, it's very correct. So the standard deviation of what? What is the square root of that? 1.195. Let me just write it to 3. Okay. Let me write everything and then we approximate to 3 significant figures. 5229. This is what you found?
Yes.
Good. So now we can approximate that one to 3 significant figures. Okay? So SD therefore is Z. What is it to 3 significant figures? This one again?
1.1.
Yes, Nancy.
1.1.
Yes, that's very good. So these are 3 significant figures. Yes, Mary, you have a question?
Yes. On the part where we find the standard deviation, when we do that square root, why is it that we don't use the one where we run the loop and then use the root?
So it will be slightly different. Yes, it will be the same, but it will be slightly different. So it may end up giving us the wrong standard deviation. It will be almost the same, but there will be that slight difference. Maybe you can try it. To one free time, you try it. You do square root of this one and square root of this one. You compare. You will see there will be a slight difference. Yes. So that will be our standard deviation.
Yes.
Okay.
Yes.
Yes. Okay. So up Here we are clear.
Yes.
Yes. Then we use that other formula to do this one again. Yeah, the formula number 2. Okay, let's see. We can do it quickly. So now using the summation of x squared over n minus the mean squared. Okay? So what this one means, we just have to square the data and then add it up, right? So for the first part, it will be, what is the first data? So it was the first one is 4. So we will do 4 squared plus 1 plus 3 plus
5 squared.
plus
3 squared.
plus
2 squared.
plus
3 squared.
3 squared. Yeah? Good. So over 7 minus the mean. Yeah? What did we find to be the mean?
3.
3 squared. Right?
Yes.
Yes. And then here, okay, 4 squared?
16.
16 plus 1 plus 9 plus 25 plus 9 plus 4 plus 9 over 7 minus 9. And when we add everything here, those with calculators quickly. So this is the variance we are finding. Yes, divisor. 73 73 over 7 minus 9. 73 over 7. 73 over 7 is what? Yes, now great.
10.42.
Okay, everything now do minus 9.
1.429.
1.429. Just like this.
I should continue it. Where is the 9 put an 8?
Okay, 8.
5, 7.
5, 7. Okay, just there. Okay, can you see that this is the same as the one that we have there?
Yes.
Yes. So this is how we use this formula, and then that's SD will simply be the square root of that. 1. You said 43, huh? 4. Okay, everything that is there. 4, 2, 8, 5, 7. So you do that standard deviation, and then it will still give you the same, right? So you can see this one looks to have taken even some smaller space, compared to the other one. So this one is the simplified one, but by definition, it's this one. The difference between the mean and the data, you square, you divide by the total frequency. Okay?
Yes.
Okay. So now let us just look at one example on grouped data. Okay? Let us look at one example in grouped data, and this one is very common in our Zambian ECZ examinations.
Yes.
Yes. So let's look at one example which I've put on my the chart that we have here. Okay. So the chart we have is this one here. So we can just concentrate basically on the table of values here. Yes. So it says the following table shows the distribution of lengths of residential plots in a village. A given village, people have plots. Now these are the lengths in meters. There are those that have plots from 6 meters to 10 meters in length, 11 meters to 15 meters in length, 16 meters to 20 meters in length, 21 to 25 meters in length, and then 26 to 30 meters in length, and then 31 to 35 meters in length. So we want to see how we can find the standard deviation for that one. Okay? So let's come back to our board here so that I give you the formulas and then we go ahead and do the working of the exam. So for grouped data, variance is equal to, so now since it is grouped, so it's like the frequencies have been grouped, the data has been grouped into the frequencies, right?
Yes.
Yes. So variance will be equal to, for the first formula it will be summation of f x minus x bar squared over n. So there's just a slight difference there. We'll have to multiply by the frequency.
Yes.
For each data we'll have to multiply by the frequency. And then for that other simplified formula, it will be fx squared over n minus x bar squared. Okay? Just that small difference. And then for the standard deviation, we said it's the squared. Okay? So therefore, standard deviation will be, for the first formula, square root of the summation of f of x minus the mean squared over n. Right?
Yes.
And then for the other formula, it will be SD standard deviation equal to the summation of fx squared over n minus x bar squared. Okay? Yes. So just that slight difference there. We are just multiplying by the frequency. Okay? Yeah. But similarly, we will start by, first of all, we need to know the mean. Once we know the mean, we can go ahead and calculate. Okay? But for this one, even finding the mean as you are calculating, if you are using this formula, it's also okay. Okay, so let's do this one. This one will require a bit of making some kind of a table that can help you to determine the x squared, the f of x squared, and then how we can calculate the mean. Yes. Okay, so now we are going to make a table on that other side of the board so that we'll be able to see how we will get the x squared, the f of x squared, and also how we will get the mean. Yes. Okay, good. So let's move here. Okay, so we'll come up with a table where we will have the data that we have, that is the length. Let's start by doing that length. Okay, and then I'll put the x here so that we can follow each other nicely. And then I'll put the x. These are big enough. And then we go to x squared, and then we are going to have fx squared. So fx squared, it means we are multiplying the frequency times the x squared.
Yes.
Good. So this is the table that we are going to have. So the length, the range for the smallest one, 6 to 10.
Yes.
And then this 6 to 10, and then 11 to 15, and then 16 to 20, and then we'll have 21 to 25, okay, and then we'll have 26 to 30. Then we'll have 31 to 35, fine. Okay. So basically, we want to see how we can get, especially the f of x squared, which we are interested in. Okay, the x squared, and then we just substitute in there, then we find the standard deviation. So the x, this x we are using here, is the midpoint of the range. The midpoint of the range that we have. So how do we get the midpoint of the range? Someone to tell us how we get the midpoint of the range? Yes, our sonda.
We add the numbers and divide by 2.
We add the 2 and then divide by 2, right? Yes. So we add those, the lower limit and the upper limit, and divide by 2. So let's do it, Yes, let's do it quickly. 6 plus 10? 16. Divide 2? 8. Here?
26.
11 plus 15?
26.
Divide 2?
18.
18. 16 plus 20?
26.
Divide 2?
18.
21, 25?
46.
Divide 2?
23.
23. 26 plus 13?
56.
Divide 2?
28.
28. 31 plus 35?
66.
What?
66.
Divide 2?
33.
33. So these are the x's that we are going to use because we can't use the range. So that's why most of the time we call whatever we calculate from this kind of data as estimates. We call them estimates because we are just estimating. The mean that we are going to have will be an estimate, the standard deviation will be an estimate, but these estimates will help us lead to the correct or good decision if we want to make a decision on the data that we have. Right? Good. So let's see, put the f's, just the frequencies there. 2,
13. 47.
47,
33.
33,
10.
10,
6.
6. Good. So now what we'll be doing, we'll start squaring the x's that we found. So the x squared?
64.
64. 13?
169.
169. 18 squared?
2,209.
22?
909.
09. 23 squared?
1,889. 1,089.
Okay. Like this?
1089.
Like this? Okay, good. 28 squared? 28 squared? Yes, in the reason.
Going to correct with that. Starting from 2,209. Where do we speak?
You've been given, okay, so. Okay, so we have 169.
324.
Sorry about that. 324. 529. 784. That is you square 28,
Yes.
And 3 squared? That's 1089 now. So, hope that's what we are getting now. Okay, so now what we'll do, we'll now start multiplying. We multiply now the x and this to get the x squared. Multiply this times that. So 2 times 64?
128.
128. 169 times 13? Quickly?
2,900. 2,100.
2,197,
Yes.
Good. 324 times 47? 15,228. You must get that one. And then if you multiply the 3 times 529, you must get 57. Okay, if you multiply this times that one, it's easy this one. Just put a 0 there. Then this times this, 6. Okay, so now what we do, we just add these things up. So we are interested in this addition here and this because this is what gives us the n. Okay? This one gives us the summation of fx squared. So this one gives us the summation of fx squared. So we add everything now. We say 2 plus 13 plus 47 plus 33 plus 10 plus 6 to give us the total frequency, which is it? 111, eh?
Yes.
Good. And then we go to the summation of f of f times x squared. We add everything: 128, 2,197, 15,228, 17,457, 7,840, 6,534. You add everything. You get divisor 49,384. So when we are done with this table successfully, nicely like this, it's as good as we are. We have found what we are calculating, that is the variance or the standard deviation. Okay? So all we just need is now to put in the formula. So we say variance. I said you can find the mean separately, it's fine, or you can even just substitute in here.
Yes.
Variance is equal to, let's use this one now. This one is more simpler in this case. So we use the summation of fx squared over n minus x bar squared, which is the mean, eh?
Yes.
Yes. So, but we know that the mean is equal to, for grouped data,
Yes.
summation of fx over n, eh?
Yes.
We know that, right?
Yes.
Yes. And then summation of fx is the total mean. Oh, I didn't do the fx, eh?
No.
Okay, let's put a column for it. Let's just put a column for it so that we find it as well. Here. So fx is simply multiplying this, eh?
Yes.
Yes. So 8 times 2, 16, 13 times 13, 169, again 18 times 47, 846, and then 23 times 759, and then we'll have 280, and then we'll have 198. Eh?
Yes.
Good. And then when you add everything, you must get 268. Eh? Is it?
Yes.
Good. So we know that the mean can be found by that formula.
Yes.
The mean can be found by that formula. So in simple terms, we can come to this board now. So in simple terms, we just say variance. Variance will be equal to, let's write it like this now, summation of fx squared over n. And then the mean we said it's summation of fx over n squared. Eh?
Yes.
Yes, the mean, if we put that mean in there, we get that. Eh?
Yes.
Good. So we'll now just put the values that we have down there. What is the summation of fx squared?
49,384.
384 over
2,000.
the n.
Yes.
Okay. See over the total frequency.
Yes.
How many in total are these people in this village? There are 111 who had brought. Yes. So minus. Now we put the summation of who? Fx, which we just found there.
2,268.
Divide by
100.
squared. So all you just need to do, you put this in the calculator and then you find the answer.
Yes.
Let's do that quickly. Let's do that quickly. Yes?
27.41660579.
66
0579.
05. Okay, let's just end there. It's enough. And then we can approximate this to 27.4. That is 3 significant figures. You can approximate it like that. So meaning that the standard deviation, SD, will simply be equal to the square root of the variance. 4,166,05. So when we do that square root, what do you get? Square root to find the standard deviation? Yes?
We get 5.2360.
5.2360 and so on and so forth, which can be approximated to 5.24. So basically, that's how we find the standard deviation for group T data. As well as we looked earlier how we can find the standard deviation of any group T data, which actually helps us to see how important standard deviation and variance are when it comes to measures of dispersion of a data. Because if you don't know how to calculate this, then when a survey is done, you collect data and then you can't interpret it nicely, we will end up making wrong decisions. I think in just a few minutes, we can go to the chart that is at the far end there. So here I would have done the example. Now, due to time, I just want us to clarify some of the mistakes that many of the students make. Okay?
Yes.
So this is it says the frequency distribution table shows the number of hours students studied on a particular day at a college. So we have number of hours and then number of students in a table like that. So what kind of data is this? Is this grouped data or ungrouped data?
Grouped data.
We can have one to answer. Can have one to answer. Yes, Mutasi.
It is ungrouped.
It's ungrouped data. That's what Mutasi thinks. What about others? What about others? Yes? It's grouped data. Can you tell us why you are saying it is grouped data? Okay, good. No, she's correct. It is grouped data. Because in many cases, many people fail finding variance and standard deviation when data is presented in this manner. So when data is presented in this manner, most of the people misinterpret it as ungrouped data. And then at the end of the day, they use the formulas for ungrouped data, which will give them wrong answers. So this one is grouped data. The only difference with this one, for this one, there will be no need for us to find the X. There will be no need for us to find the X, because the X is already given here. The data is not given in form of a range. So data is given, okay, those that studied only for 1 hour, they are here. Those who studied for 2 hours, there. 3 hours, there. So this will be your X, you will be multiplying, you will be using that as the X the way we used it there. Okay? And then these will be the frequencies, the F's, you will be multiplying with them. Yes. I hope we have cleared that misconception. Because many of us, we usually think that this kind of data is ungrouped. So ungrouped data is simply given as a list. Okay? Okay. Then once it is put, you say, those for 1 hour, they are 5, you put them together. Then you are grouping them. Good. So I hope that has been clarified. Yes, Sylvie.
The only difference between that one and this one was estimated, and then that one was given exact.
Yeah. So this one is the actual. Sure. Thank you so much for that. And then for your own practice, which you can do it even later, I'll read the question and then I'll just write the table of the data that we have, right? So that you try it at your own free time. So for the practice question, so it says the table below shows the heights of learners. The table below shows the heights of learners of a particular grade in a school. The table below, so I'll put the table here. The table below shows the heights of learners of a particular grade in a school. So has height in centimeters, and then in frequency. Okay? So 153 to 157, 158 to 162, 163 to 167, 168 to 172, 173 to 177. Okay? So for this one there were 9, 23, 35, 27, and then 6. So the question is simply calculate an estimate of the mean, and then B, you calculate the standard deviation. Okay? So that's for your practice. You try to do that one. Do we have any questions as we reach towards the end of our lesson? Any questions?
No.
Okay. Yes.
Sir, is it possible for them to bring a question like in that form and then it's ungrouped that?
Yes. But if it is in that form, then it will clearly show that this is ungrouped data. Okay? You won't have if frequencies are grouped like that, then it is grouped. Okay? Yes. How many times do they appear? Okay. So usually it won't have the frequencies grouped like that. So once the frequencies are grouped, then it is grouped. We have come to the end of this lesson. For me, Moses Marama and the TV crew, it's bye-bye for now. Until next time.